A machine puts C caps on bottles in M minutes. Looks like we got a nice little algebra problem going on here. I'm loading algebra into my brain. I'm probably going to be just modeling some algebraic equation, maybe multiplying some fractions with algebraic expressions in them. How many hours will it take to put caps on B bottles? The machine puts C caps on bottles, C caps per M minutes. Translating this from words into expressions, how many hours will it take to put caps on B bottles? Well, I'm assuming we're doing one cap per bottle, right? I mean, C caps, and we know how many caps go on bottles, but I think that to put, if they'd said put B caps on bottles, that might have been more in line with the way that the question was phrased, or the statement was phrased. But yeah, I think we can have good confidence that there's one cap per bottle. If I have B, if I want to bottle B bottles, I think this is going to be a division. B caps or bottles are going to take this fraction divided by this fraction is going to be B over C times M minutes. It will take BM over C minutes to do B bottles, and BM over C minutes times 60. No, I want to get rid of the minutes. 60 minutes per hour is going to be BM over C hours. BM, well, what happened to that 60? Be careful, buddy. BM over 60C, BM over 60C, which incidentally, this notation isn't really good the way they've done it. They should have used parentheses. BM over 60C, you just write that. That could be interpreted as BM over 60 times C, because if we're doing addition, multiplication and division, we do the order of precedence of the operators is left to right. So B times M divided by 60 times C is interpreted actually as B times M over 60 times C, but I think they're, so I don't like the way that they wrote that actually, but when they write BM over 60C, I mean that's kind of more just shorthand for just think of this line being a fraction, and really they're trying to write this. So I think that I've got my answer here, even though I don't like the way, I don't like a couple things about the question. I don't like the way that they wrote the answer, and I think that they should have said how many hours will it take to put C caps on bottles, or they should have said a machine puts bottles on, puts caps on C bottles. They've left me to assume that there's one cap per bottle, which seems like a reasonable assumption, but who knows? There could be bottles with more than one cap on them, right? Maybe, theoretically. So they're making assumptions here that aren't stated. This doesn't seem like a nicely mathematical, rigorously clearly stated question to me, but I'm being more technical than I need to be when I start criticizing the questions. But the more important thing here being just the method that I used was I always like to write out my units, and in a question like this, the critical thing is, I mean, all of these answers have B, C, M, and 60 in them. That's one thing that I do like about this question. Everybody knows, I mean, the only choices are, I mean, C, M, B, the number of bottles we're trying to bottle, the number of caps that the machine can do in M minutes. Each of these variables, you know, B has a role to play in the answer, and the conversion from minutes to hours clearly is going to involve the constant 60 somewhere. So the answer has something to do with a 60, and something to do with a B, and something to do with an M, and something to do with a C. The only question is in what gets multiplied and what gets divided, what is on top, what is on bottom. And the way that I always like to do that, rather than having to think about, well, let's see, you know, rather than thinking, okay, I've got this machine, and it, you know, if it can do B bottles in M minutes, or C caps in M minutes, and rather than trying to think through it, I don't even have to think about machines and bottles and caps when I put it into a mathematical expression, and I write my units, and I effectively do algebra on the units, where caps divided by caps cancels out, and 1 over minutes turns into a minute. I'm effectively doing algebraic manipulations on my units. Then then I know that if I get the right units, then I've almost certainly pieced my my expressions together in the right way. So that's why when I knew that I had C caps per M minute. I knew that per, I translate per as division, as a fraction. And then when I knew that B caps were going to come into play somewhere there, well, I didn't want to multiply, because if I multiplied B caps, then I would have units of caps squared. That's not going to do me any good. I could, you know, I could divide. I could do C caps per M minutes, and I could multiply by 1 over B caps, and that would get my caps to cancel out, but then I would have units of 1 over minutes. That's like a frequency. I don't want to know a frequency. I want to know the number of minutes. So that kind of got me to thinking, well, I'm going to write B caps, and I want to divide by my C caps per M minutes, knowing that if I do this as a division, my caps are going to cancel out, and I'm going to end up with minutes as a unit. I guess a clearer way, that's kind of my own way of thinking about things, a more proper way to do it maybe would be, although I mean my way works, maybe a more proper way to think about it is that every M minutes this machine can do C caps, and if it can, every M minutes it does C caps, then that's the same as saying every M over C minutes it can do 1 cap. Well, if I want to do a total of B caps, M over C minutes for every 1 cap times B caps, again, the caps effectively cancel out, and that's BM over C minutes. And then the conversion from minutes to hours is, that to me that's more intuitive, because I think about time units a lot more frequently than I think about machines putting caps on bottles. This many BM over C minutes, 60 minutes in an hour. Although again, I could get confused on whether I should multiply by 60 or divide by 60. So it can be helpful to write the units out and say, do I want to, and you even saw me up here, I did, you know, I was going to write a 6 in the numerator, and what saved me was I said, okay, I know I want to cancel out these minutes, so I know I want to get my answer in terms of hours, so I know I want my minutes in the denominator so that they'll cancel out. And that's how I knew I should divide by 60 rather than multiply by 60 to get BM over 60C hours. And basically I figured out the way that I concluded that the B and the M multiplied together, and this in the numerator and the 60 and the C were in the denominator, rather than any of these other combinations of putting B, M, and C together. The way that I figured out that this was the right way to do it was simply by making sure that my units would cancel out, and this expression gives me hours, units in terms of hours. The B and the C are both in terms of caps. M is in terms of minutes. 60 is in terms of minutes per hour. And so if I did algebra, if I do caps times minutes divided by minutes per hour times caps, I get units of hours. And presumably any of these other configurations of multiplying, if I just look at the units involved, I won't get hours as my units. I'll get something like, I mean, I can do an example here. What if I did this? B over 60 cm. If I just write out the units, the units on B is caps. The units on 60 is, 60 refers to minutes per hour. C has to do with caps. M has to do with minutes. So, well, the caps and the caps cancel out, but then I've got units of hours per minute squared. That's no good. I'm looking for an answer in terms of hours. So likewise with any of these other guys, if you just do algebraic manipulations on the units, you're not going to get an answer with hours as your unit. So that's how I know the right way to piece things together to get the right algebraic expression.